In this video, we'll look at the STPM Math T past year question for 2015, Section A, Question 2. So here we have the rth term of an infinite series, okay, given by 1/3 power 2r plus 1 plus 1/3 power 2r minus 1. So there are two parts to this question. Question A is express the rth term in the form of a over 3 to the power of tr plus 1, where a is a constant, and B, find the sum of the first n terms of the series and deduce the sum of the infinite series. So for part A, okay, what we'll do is we will first factorize the 1/3 from the rth term. Okay, so since we need to factorize this in the form of a over 3 power 2r plus 1, so we will factorize the term that has 2r plus 1 here. So in this case, the rth term will be 1/3 power 2r plus 1, okay, and I'll factorize it, okay, from here. So the first term here will be 1, okay, and then the second term, which is 1/3 power 2r minus 1, will be divided by 1/3 power 2r plus 1. Okay, now for this part, we will simplify the second term. So this is 1 over 3 to the power of 2r plus 1. Okay, and then this is 1. And then when we have a division, okay, remember when you have division, if it's a to the power of m divided by a to the power of n, that will be a to the power of m minus n. Okay, so this will be 1/3 to the power of 2r minus 1 minus 2r plus 1. Okay, remember the bracket here. And if you simplify this 2r plus 1, okay, this is 1 plus, and then this is 1/3. So 2r minus 2r, that would be 0, okay, and negative 1 minus 1, that would be negative 2. So what becomes of 1/3 to the power of negative 2? So 1/3 is equals to 3 to the power of negative 1. So 1/3 to the power of negative 2 is equals to 3 to the power of negative 1 to the power of negative 2. So negative 1 times negative 2, that would be 3 to the power of 2, which is 9. Okay, so we have 1 over 3 to the power of 2r plus 1. Okay, and this is 1 plus 9, which is 10. So we have 10 over 3 to the power of 2r plus 1. Okay, so that concludes part A, okay, which is to express the rth term in the form of a over 3 to the power of 2r plus 1, and a here is equals to 10. Okay, so we are done with that part. Now, for part B, let's find the sum of the first n terms. Then we'll find the sum of the infinite series. So in this case, given this n term here, let's try to write out the series. Okay, for this rth term of 10 over 3 to the power of 2r plus 1. Okay, let's try to write this out. So in this case, u1 will be 10 over 3 to the power of 2 times 1 plus 1 will be 3. Okay, and then u to the power of 2 will be 10 over, this is 3 to the power of 2 times 2, 4 plus 1, 5. Okay, and then if you continue on, u to the power of 3 will be 10 over 3 to the power of 7. Okay, and so on and so forth. So you can see that the series here is a GP, is a geometric progression. Okay, where this is the first term. Okay, this is our first term. Which is, in this case, I can write this as a equals to 10 over 27. And the r, the common ratio, will be the ratio of, let's say, I'll take the second term divided by the first term. So this is 10 over 3 to the power of 5 divided by 10 to the power of 3 power 3. Okay, so in this case, the rth term here will be 3 to the power of 3 divided by 3 to the power of 5. Okay, so in this case, we conclude that r is equals to 1 over 3 to the power of 2. Okay, so the common ratio here is 1 over 9. So we have the first term, we have the common ratio. So the sum of the first n terms here is based on the formula where we take the first term a, and then we multiply by 1 minus r to the power of n, okay, divide by 1 minus r. Okay, since here r is less than 1, okay, here r is less than 1. So we'll use this formula here. So the sum of the first n terms is based on a. Okay, a here is 10 over 27. Okay, 10 over 27. Okay, and then this we put a bracket here, 1 minus, and then this is 1 over 9 to the power of n, and then divide by 1 minus 1 over 9. So for the denominator, okay, for the denominator, when you take 1 minus 1 over 9, that is 8 over 9. Okay, and then here you have 10 over 27. Okay, so we can now simplify this. So in this case, we have 10 over, this is 10 over 27 times 9 over 8. Okay, and then this bracket 1 minus 1 over 9 to the power of n. So we have 10 times 9 over 27 times over 8. So in this case, we'll take 9, okay, divide, this is 3. Okay, and then divide by, we divide by 2, this is 5, and this is 4. So this is 5 over 12, 5 over 12 times 1 minus 1 over 9 to the power of n. Okay, so this is the sum of the first n terms. And then for the last part, which is to find the sum of the infinite series. So what we'll do here is we will put, okay, so as n approaches infinity, so what happens is 1 over 9 to the power of n will approach 0. So in this case, the sum to infinity will be equals to 5 over 12 times 1 minus 0, which is 5 over 12. Okay, so your final answer here is the sum to infinity for this series will be 5 over 12.